Now I want to show you how to use Excel to do a regression. Most of the time when you're in Excel, and right now I'm in Excel 2016, you're going to be on the Home tab. If you want to do a regression, you're going to need to get over to the Data tab. If the Data Analysis Tool Pack, if it's been added, usually it's on the right hand side. You find the Analysis group and just click on Data Analysis. Now we want to go down to the R where the regression is, and you can either click on regression and then click on OK, or you can double click. Now the input Y range, what I'm trying to do with this particular problem is I want to be able to predict the number of cars sold based on the number of TV ads. So cars sold is the Y, it's the dependent variable. So I click inside the box, I'm going to click on the label, cars sold, and then just hold down the mouse and select all of the data values. And then you repeat that process for the X for the independent variable. I'm trying to predict cars sold based on the independent variable TV ads. So I'm inside the box for the input the X range, and I just click on that label and then hold down the mouse and select all the values. Now check the box for labels because we did include the labels. I want the output to be on this same sheet. I want the confidence level to be 95%, so I don't really have to do anything to the confidence level. By default it's going to be 95%. But to get that to get that output starting down here at A8, I've got to select the output range, and then I can just type in A8, but I can just use this little icon over here that has a grid with an arrow in it, and just click on that, and then just come over here and click on the cell where I want the output to be. And that's it. That's all you really have to do to get just a basic regression. So I'm going to click on OK, and it'll solve the problem, and it'll put the answer down here starting in A8. Now that was pretty simple. But there's a problem here when I scroll down here and look at this, in that some of these columns are not wide enough to read what's inside there. Now this is a little trick that you can use. If you go up here between the rows and the columns and just click on that little cell up there in the corner, what that does is it selects the entire sheet, and then you can position the cursor between any two columns and you get that double-headed arrow, and then you can just double click and it spreads everything out so that you can read it. But it starts up here at the summary output. You have some regression statistics. You have in the middle what's called an analysis of variance table, or Anova for short. And then down here at the bottom, this is really what we're looking for right now, is we want to know what that regression equation is. What's that estimated regression equation? The y-intercept, the value is 10. The slope, the number that you're going to multiply times x, that value is 5. But the first part that's explained inside the PowerPoint slides is this part down here, which I refer to this as the coefficients table. But it gives you the slope, it gives you the y-intercept, gives you these t-statistics that you can check for whether or not this is a good variable, whether or not that y-intercept, whether or not it's going through the origin. Over here on the right hand side you get interval estimates for the population regression coefficients. Now the p-value that's for the independent variable for TV ads, this number, it's in E25 in this case. This is the same number that's up here in F19. The Anova test is an F test, but in simple linear regression It's just looking for a relationship between the independent variable and the dependent variable. And you can use that p-value and compare it to your level of significance, and you can see whether or not that relationship, whether it's significant or not. So at the 0.05 level of significance, this p-value is smaller than alpha, and it says it's a good relationship. But if you were doing this test at the 0.01 level of significance, it wouldn't be a strong enough relationship, because 0.018986 is bigger than 0.01. So it's okay at 0.05, but it's not a strong enough relationship if alpha is 0.01. Now up here in the regression statistics, there's a statistic that's called R squared. Now we're going to refer to that as the coefficient of determination. The symbol for it is R raised to the second power. That number tells you something about this regression model. About 87.7% of the variation in the cars sold, the variation in whatever the dependent variable is, about 87.7% of the variation in cars sold may be attributed to this linear relationship between TV ads and cars sold. But the predicted value is 10 plus 5 times the number of TV ads. But that accounts for almost 88% of all the variation in this variable. And that's pretty good. Now, the number up here at the top, the multiple R, this would be the correlation coefficient, except Excel doesn't put the sign in it. If you want to know whether it's positive correlation or whether it's negative correlation, what you're going to have to do if you use this tool in Excel is to go down here and look at the slope. The value of the slope is 5, but it's a positive 5. So that means the correlation coefficient is positive. If you have a negative relationship, then that slope is going to be negative. But whatever the sign of the slope is also going to be the sign of the correlation coefficient. But it's fairly easy to use this tool in Excel, and it takes all that computational burden out of this. You get all these numbers, but what you're going to be able to have to do is to look at this output here and answer questions based on this output. You're going to have to be able to solve problems based on this output. But using the tool, it's really fairly simple in Excel.